So to set up this section, where our rip is sitting at, as you can see, I actually did change the diagram. Um, there are a couple things we're going to talk about first, okay? And they're not going to go into depth. It's just to give you understanding. Okay, the first thing we're going to talk about is a plane. Okay, and if we go back and take a look at it from a analogy that I'm going to use is D&D, Dungeons and Dragons. Okay, so look at it from this perspective. We as human beings, okay, live on our plane, okay, our dimension, okay. Now, if they're gods, okay, those gods live on their plane, okay, their universe, or however you want to look at it. From doesn't really matter. Gods come from a different plane, okay. So now, if a god with power, okay, comes into our plane, leaving their area of where they live, okay, they powers must obey the laws of physics of our plane. Okay? Now, if I kill a god on our plane, he just returns to his plane. Okay? The idea is the plane is a domain. Okay? It's an area. Okay? So in this house, okay, in my room, okay, I have this is where I have a desk, okay. That desk is where I do my work, my recordings, okay. All right. So that means now this is you can okay. So this is work for me, okay. All these videos is work, okay. From your perspective, it's school or it's entertainment, all right. Okay, but let's not get it twisted. I'm not here to entertain you. Okay? I'm here to teach you. All right? Whether it's a philosophy or a learning. Now, as we go through this, okay? Let's look at how my videos are. Now, we have our rants, okay? All right. Now, that's the rant plane. We have, hold on. We have our network philosophy. Now, okay, on that plane also lives life philosophy, okay, using life examples in a way to educate in that fashion, okay. And then we have our actually I lost my train of thought. I don't know where I'm at now. So still, uh, hold on for a second. Okay, so yeah, I keep putting the headphones down because I have to the headphone sits over the actual glasses, that sit on my ears. Okay, that part of the glasses. So every time I have to wipe a smear, which apparently I have issues with glasses. Okay, I have to take the headphones off. But nonetheless, okay. So kill a god on his plane, the god is dead. Okay. Nonetheless, the concept is, okay, like I explained, the philosophy plane, the network philosophy, the life philosophy lives on the same plane because it's a philosophy in itself. You got the teachings, okay, and then you got the rants. All right. So, or I should say the lectures, teachers and lectures, and then we have the labs, okay, which the labs and the teaching are on the same plane. The concept is it gives you understand what I mean by planes. Okay, so in our router, in our switch, in our firewalls, we have three planes. Okay, now the first plane is called the management plane. Okay, now management from the concept of me consoling into the device or setting up network reachability to that device via a network, okay, which we can reach from another state, from another country, doesn't really matter. However we get to that device, okay, via any type of network, all right, we can set up a management plane, okay, saying that if I can ping the device and communicate with it, all right, I can log into it, all right, the second I log into this device, that device is allowing me access through the management plane. Okay, all right. There's software that manages that plane. Okay, so that allows me to go into privilege exec mode, config T, shut down interfaces, enable router protocols, and they put in routes into my routing process. Everything. I get to do whatever I want with that device. Okay, I get to manage it. All right. What better way? Because now I don't have to physically be there on that device. That gives me unlimited God power, right? Okay. So the next one is called the control plane. Now, these concepts we're not going deep in. Okay, it's just to make yourself aware of this. Okay, maybe we'll have another lesson about it, but at the same time, it's a hard concept for most people. Okay, because they really don't know exactly what's what. So we know what the management plane is. That's simple. Okay, but what is really the control plane? Okay, the control plane is where your routing protocols sit. Okay, because we call it the control plane. Okay, because they get to control what goes in our routing table. They get to control sharing routes back and forth and the routes that they receive. Okay, because what you haven't learned yet is I might be getting 20 routes. Okay, but I can say, hey, distribute this route here and do not allow it in my routing table. Okay, that is the controlling of the routing table. Okay, now also the cool thing about it is if the routing table, okay, is propagated by the actual control of the routing, I'm sorry, of the routing protocol, even static routes. Okay, all right, that's something you manually putting that in there. Okay, so that will be part of the control plane via theory. Now, okay, here's the thing. What I just said, okay, could be true, false, or gray area. Okay, the bottom line is, all right, you want to know how Cisco sees it? Go talk to them, which will be Cisco documentation. Okay, and you can literally ask the question even in Google: is static routes part of the control plane? Okay, all right. So, but again, those little so-called little pieces that I don't go in detail for, hey, it's a question or I'm doing air quotes now, or a philosophy, a network philosophy for you to actually think about, okay, with the mixture of documentation, okay, all right. Now we talk about philosophy. Philosophy is the concept of a thought, okay. It's not about right and wrong. It's about a thought, okay. All right. So now the control plane also dictates which way my traffic is going to go. Now, if we look at every device as a single entity, okay, router one, all right, let's take a look at router one here, which we're not taking a look at it, we're just looking at the diagram. All right, so now router one, actually router two, okay, has 1.1.1.1 that was learned from router one as they're sharing routes, okay, in this topology. Now, how router 1 is learned, or I'm sorry, how 1.1.1.1 is learned from router 2, okay, we can control either by the default attributes of that routing protocol, which that is controlling how it's going to send data to that particular network, or we can manipulate, okay, and manipulate and change that control, okay, of the control plane, all right, by saying, hey, okay, if from 1.1.1.1, I'm learning it from G1 and G2. However, when I need to communicate with it, go down G2, not G1. Okay, now if G2's route or path is broken, go to G1. Okay, All right, or you could say, hey, I'm learning on G1 and G2. Okay, send a couple packets here, send a couple packets there on G1, and then a few on G2. Okay, so that's the control plane. It controls how we get to that route. That is the best way I could say it. Okay, and we're done on that because anything else more, okay, is getting deeper into that concept. All right, which we're not going to do. Now, the data plane. Think about it like this. Okay, we got our control plane, which tells us which way to go, but then the routing protocol's job is to insert that into the routing table. Okay, now we got our network queues and we got our forwarding interface, okay, which that's the whole purpose of doing our route lookup into the routing table. Which interface am I going to send this data out of to get to it? Okay, whether it's G1 and G2 together, or is it G1 and G2? G2 might be the primary and G1 is a backup. Okay, depends on how you set up your control plane. Okay, now keep in mind the routing protocols, OSPF, EIGRP. Let me slow down. And BGP, okay, have their default methods of doing things. Okay, obviously that's good because we could just set a routing protocol and just let it do its thing. Okay, we don't have to manipulate, but the power of managing, having a managed switch or router or firewall, is we got full power and control. Okay, so every time we make changes to a router protocol, we are making changes to the control plane. Every time we are actually changing parameters of of our management to access a device, we're manipulating the management plane. Now the third one is going to be the data plane. Okay, the data plane's only job, okay, is to get that data forwarded. Okay, so I'm looking up into the control plane to find out what interface we're going to, and now control plane, I'm going to exit out of that and get. Now when I say exit out of it, it's guys, it's just an example. It doesn't mean that's what we're doing. And I'm going to go into the forwarding aspect. Now I'm going to build my my layer 2, my layer 3 information. Okay, I got ARP already set up, all that. So now I can encapsulate this packet, and then I'm going to um, either serialize or turn that information into light or bits, okay, which is all the same stuff. So it's electrical signals or light, okay, that I'm going to send it down. But I need to put that data on the wire, okay. So now I'm setting up the frame and everything in order to force it out that interface. And before I do that, I'm going to slide it right into the output queue. All right, this is me forwarding data. So that is the data plane. Okay, so if you look at it, all right, that data plane's only job is to take the information from the router table and ARM table and build our encapsulation and put it on the wire and send it on its way. Management plane, control plane, data plane. Okay, that's it. That's all we're going to talk about. Another thing we're going to talk about is route distribution. Okay, now route distribution is interesting, and I'm only going to talk about one concept because again, these are not major topics that we're talking about at the moment. They're just topics so we can talk about the next section, okay? Because we are going to have to redistribute routes into OSPF from the RIP domain. Now, RIP is a routing protocol, okay? So it doesn't matter what routing protocol we use. Any routing protocol that has routes learned in its routing table, those routes from that routing protocol can be redistributed into another routing call if there is a router that is running both routing protocols. Okay, like router 6. Router 6 is running OSPF, it's going to be running RIP because we can't exchange routes without two or more routers being in that particular routing protocol's domain. Okay, and in the RIP domain, okay, we're going to have 7.7.7.7, okay, and we're going to redistribute it into OSPF. Now, here's the thing. When I do that redistribution on router 6, we're only going to, and that's the thing, we're going to go into OSPF and we're going to say redistribute RIP, okay? And here's the thing, whatever routes are learned on router 6 as a RIP route, that's the only routes that's going to be redistributed. Meaning that the 192.168, that 4 network, okay, will never be redistributed into OSPF, okay, because it's not a learned RIP route. It is a directly connected route in the routing table, but not a RIP route, because directly connected has a administrative distance of 0. Have we talked about administrative distance yet? I think we have. Okay, has an administrative distance of 0. Okay, if I'm correct, do your own research. All right, and so it wins. Okay, so if I was advertising from router 5, the 4.0 network, okay, all right, and I'm sending that information to router 6 and it's being learned on G1, okay, gigabit 1, okay, all right. Since router 6 has a directly connected interface and has an administrative distance of 0, it wins the actual so-called election, or lower administrative distance, and puts that in the routing table. So it's never going to put it in the routing table a 4.0 network learned from G1 because it has a 4.0 network directly connected, which means someone messed up somewhere. All right. So now, regardless, in order to get the 4 network, because you got to understand, 7.7.7.7 will get redistributed into OSPF. OSPF is going to take it from area 2 into area 0 as a LSA3. LSA3. Okay, that's a summary route. Now, router 1 knows about 7.7.7.7, and it's going to say the next hop for that is going to be router 5. Okay? But when router 5 gets that packet, okay, it learned it from router 6. Okay? Alright? The next hop is router 6. Okay? And since it's directly connected, 7.7.7 was learned by router 6, next hop is 7. We are good. But if that's broken in any way down the way, that 4.0 is not in that routing table, like my last example, all right, because 5 has 4.0 from another direction. So it's going to send that packet somewhere else. Okay? And guess what? Okay? It's going to go to the wrong direction. But you got to understand, okay? In order for me to take the 4.0 network and put it into OSPF, I have to say redistribute connected. Okay? This is a misunderstanding in a lot of ways, and I hope I made it. I hope I made it clear. Okay, this is, you're going in there, you're trying to get your route set up, and you just forget to do redistribute connected, which is a common thing. Okay, all right, and now you can't figure out why you can't get there. Okay, all right, so with RIP, oh, hold on, I forgot my glasses. So with RIP, EIGRP, OSPF, okay, these are directly connected routing protocols. Okay, if I want to set an adjacency with OSPF with router 1 and router 6, I'm going to have to create a tunnel, which is something we haven't discussed with either, because that logical tunnel interface is now a directly connected interface from a logical perspective. Okay, and the routing table sees it as a real interface. Okay, now the path to get to router 6 might be this, and that's how the packet is going to travel because it cannot bypass the physical path. But that logical interface from here to here, okay, from its perspective, is a directly connected interface. We're sending it through the tunnel, okay, which we'll get a better understanding from that when we, talk about tunnels. Okay, so now, but from the concept of BGP does not have to be directly connected. That means I can set up an adjacency for BGP from router 1 to router 6 or even router 7. Okay? Alright, as long as I have reachability from source to destination, I can create a BGP session and exchange routes. Okay? Now, that means if I do not set up and advertise the 4.0 network, okay, and the next hop from a BGP perspective is the 4 network, okay, it's going to be broken. So there is a reason to redistribute connected interfaces, okay, so, and that is one of those, and that's it. That's all we're going to discuss about these 3 topics, okay. So now, be strong, be determined, be Cisco.